Question 1 is a straightforward SUVAT question. It's important that we go through it the right way. So we start by writing out SUVAT and we look through. What do we know? It says what the speed was to begin with, so that is u is known. Just to get off, you can write the values in. It says what the speed is at the end, so v is known. Again, I'm ticking it off, you should write it in. The time is given, so you write it in, just ticking it off there. And you're asked to find the acceleration. And you're also asked to find the distance moved. So you write your SUVAT, you put the values in, and then you choose an equation. So when you're trying to find the acceleration, if you know u and v and a, you know u and v and t, to find acceleration, it should be fairly easy to choose an equation that's got u and v and a and t in it. To find the distance it moves, then you've got a choice. Once you know the acceleration, you can use either of those two, or if you know u and v and t, you don't need to use acceleration at all. You can use that equation, can't you? So the second question is also a straightforward SUVAT question. So we should be getting used to SUVAT questions by now. We should be finding them quite easy, but it is important that we do carry on using the proper method. And it's much easier if we keep ourselves organised and we write down SUVAT. Let's go through and see what we know. It tells us the speed as it lands. That's the speed at the start of the question, so u is known. You can write its value in. It doesn't tell us what its speed is at the end, but it does say it comes to a halt. So that really tells us what the speed is at the end. So you can write in the value. It tells us how far it travels while it's coming to a halt. So S is known, you write it in. Now the two missing things, the braking time we're asked to find, and it asks us to find the deceleration. Of course the deceleration, that's the acceleration, that's A. And we know it's slowing down, so we know we're going to get a negative value for A, which is why it calls it a deceleration. So, we need to choose an equation to use. To find the braking time. Well, if we know S and we know U and we know V, we want to find T. Looks as if we're looking at that as the equation to use. It's the only equation that doesn't have acceleration in it. So that's how we find T. And then when we're trying to find A, the acceleration, the question says deceleration, but we know it's just going to be a negative acceleration. Trying to find A, then we can take our pick. I'd be inclined to use that one because U and V and S are all given in the question, so A is the only thing we've got to find, so I'd be inclined to use that one. Question 3 is a bit more complicated because there's two parts to the motion. So the sensible thing to do is to be organised and to treat the two parts separately. So for the first part, we use SUVAT for while it's speeding up, and it says it accelerates from rest. So if we know it's at rest, then we know what the speed is to begin with. It doesn't give the value, but a bit of common sense. If it's at rest, we know what that speed is. And it goes up to a speed of 6 meters per second. So we tick it off so that we know it, you write the value in. And we know the time it takes to accelerate. What we don't know is we don't know how far it travels while it's speeding up, and we don't know its acceleration. And part A of the question is to calculate the acceleration. So if u and v and t are known, then choosing an equation that's got acceleration as well as those should be easy enough. Then to find the distance travelled, if you know u and v and t, you should be able to find the distance travelled. For the second part of the journey, well, it tells you the second part of the journey it's slowing down. It says deceleration, so it's like negative acceleration, it's slowing down. And the question tells you how far it travels, so S is known for the second part. Now it doesn't tell you anything else about the second part of the motion, except it comes to a halt. So we know what the speed is at the end of the second part. It's stopped. You can work out what that speed is. If it's not moving at all, you know its speed. And although it doesn't tell you the speed in the second part, we know that at the first part it's speeded up. And we know how fast it was travelling at the end of the first part of the question. Well, the speed at the end of the first part, that's the same as the speed at the beginning of the second part. So for the slowing down part, we know S, we know U, and we know V. The thing we're asked for is we're asked for the acceleration. The question uses that word deceleration again, but we know it just means you're finding the acceleration and then you'll find that it's actually got a negative value. And you've got to find the time taken. So to find the acceleration, well, the things that we know are U and V and S. And there is an equation that doesn't have T in it. It's an equation that's only got U, V, A and S in. So that's the equation I would use to find A. Once you know the acceleration and you know U and V, you can use U and V and the acceleration in an equation that will tell you the time. The third part of the question asks you to plot a graph of speed against time. Well, we know it starts at rest and goes up to some maximum speed, and then we know that it slows down and comes back to zero. So the graph will be that sort of shape. I've drawn that really roughly. I've not tried to put any numbers on. When you draw it, you can sort of show some numbers on the scale. Then it asks you to use the graph to find the average speed for the journey. But if you remember that average speed is the distance travelled divided by the time. And you can find the distance travelled by working out the area under the graph. So if you work out the area under that graph, that's the distance. You know what the total time is for the graph. So you can find out the average speed by dividing the distance by the total time. Question 4 is a graph question. The first thing it asks is to find the initial acceleration of the athlete. When you've got a graph of speed against time, the acceleration is the gradient. So to do this question properly, what you'll need to do is you'll need to draw a tangent. So you need to take a ruler and a pencil, and since it's not your book and not to use the books again next year, very, very faintly draw a line that's a tangent to the curve. And you can find the gradient of that line. And then when you've done that, you can rub it out again so that next year's person does ask the other question for themselves. To find the distance moved in the first 2 seconds, well, we know that distance is the area under a speed time graph. Because it's a curve, you're going to be estimating by counting squares. Quantum squares are actually rectangles, aren't they? You have to remember, when you've counted the number of squares, you've got to remember what each square represents. Each square represents 1 second horizontally and 2.5 metres per second vertically. So each square represents 2.5 metres. So the next part of the question, part C, is the distance moved in the next 2 seconds. Well, if you can find the distance for the first 2 seconds, you can use exactly the same method to find the distance for the next 2 seconds. And then the final part, the average speed over the first 4 seconds. Well, you've just worked out how far it's gone in the first 4 seconds, and we know it took 4 seconds to do it, so it should be really easy to find the average speed.